So we got some questions. We've already studied about how quadratic curves sort of interact with lines. Now we're trying to solve out these questions from past papers and just look at this first question. So it says a curve has this equation which is given to us by this thing right over here, and then we're told that a line has an equation. We're given that by this following equation, and it says find the set of values for C for which the curve and the line intersect at two distinct points. Okay, so before we head on to this, I want you guys to look at the equations, and if you look at the equations, you will see that there are these values of C, and we don't know what these are. They're not a number, they're just a constant given to us as C, and we need to find the values for these C's. Right? They say find the set of values for C for which the curve and the line intersect at distinct points. So what does this tell us? What does this distinct point tell us, right? Don't worry about the values for C for now. Just look at this distinct point right over here. This is where your answer lies. So they're telling you that the curve and the line need to intersect at two distinct points. And how do we find that? Well, we talked about in a previous video, if you watched that, we talked about this merged equation, right? And the purpose of this merged equation is to tell us the points of intersection. And so the merged equation is going to have a discriminant. The merged equation tells us the points where the line and the curve intersect, and it has a discriminant. Right, so I'm going to write it with a capital D. It has a discriminant, and if that discriminant is a positive number, then the curve and the line intersect at 2 points, two distinct points. If the discriminant is equal to 0, they intersect at 1 point. If it's a negative number, then they intersect nowhere. And so the key lies in this idea that the merged equation needs to have a discriminant that should be greater than 0. So this is a D, okay? This is not an O, this is a D. And why does it need to be greater than 0? Because that means it's a positive number. So what we're trying to do is we're trying to find the discriminant and we're trying to put it equal to 0. But for that, we first need the merged equation. So let's find out the merged equation. How do we do that? Well, you take the equation of the curve, you take the equation of the line, and you put them together. So basically y is equal to x squared plus 2cx plus 4, and then the line is equal to 4x plus c. So you put these equal, you say y is equal to y, right? This y is equal to this y, and then you just substitute their equations. So we have this thing is equal to this thing. Right, and now let's just bring all of this over here to the other side. So we are going to have x squared plus 2cx. I'm going to place this x term with this x term. So this is going to be negative 4x. And I'm going to place this c term with this constant, right? This c is a constant term. It doesn't have an x with it. So I'm going to place it with this constant term 4, which doesn't have an x with it. So plus 4 minus c is equal to 0. And I can actually see that this x and this x is common. So I can take them out as common. So that would basically look something like x squared plus 2c minus 4. And I'm taking the x out as common. And then I have 4 minus c. And all of this is equal to 0. Okay, so now this is my merged equation. Now the discriminant of this, so I take the discriminant from this, I'm going to say D, that discriminant has to be greater than 0. So what is the discriminant in this? Well, if I, this is basically this equation, this merged equation, it's in its standard form. It's in the form ax squared plus bx plus c. All of this is c, right? All of this is b, and this positive one right here, which we cannot see, is basically going to be a. So the discriminant is basically b squared minus 4ac, and we need to put that greater than 0. So b squared is going to be 2c minus 4 squared minus 4 times 1 times 4 minus c, and this is greater than 0. So I can apply the identity over here, which is basically a minus b whole squared, and so that is just going to be a squared plus b squared, so that's going to be 16, and minus 2ab, right? So that's going to be, I believe, 16c. I think I did that right. And then all of this is going to solve out to give us negative 16 and positive 4c, and all of this is greater than 0. So let's simplify this a bit. We can see we have this term with ac, this term with ac, this is a constant term, this right here is a constant term. So if we solve this out, we are left with this positive 16 cancels out this negative 16, and we are going to be left with 4c squared, and the negative 16 and positive 4c should give us negative 12c, and all of this is greater than 0. So what do we have right now? Well, if you look at this, this is basically a quadratic inequality, and so we need to solve this out, but in the method we solve out quadratic inequalities. So how do we do that? Well, the first step is to factorize, and so for factorize we usually apply middle term break, but we can see that we don't have a c term in here, right? If even there was a c, so I'm not talking about this c, right? I'm talking about the c term that is present in ax squared plus bx plus c. I'm talking about the c term that is in the standard form, the constant term. So in this right over here, we don't have that constant term, right? We don't have it, and so we don't have to apply middle term break. We can just factor this out and have our answer. So if we factor this out, we can see this thing has a c, that thing has a c, and 4 and 12 are common. So we can take, actually we can go ahead and take 4c out common, and we will be left with c minus 3. This is basically the factorized form, and so you can even write it like this if you want to, if plus 0 or minus 0. You can even write it like this. Both of these things are correct. They're the same thing, just written differently, right? This 4c plus 0 is just going to be 4c. So what did I do? I have a quadratic inequality. I took out commons because I don't need to apply middle term break. There's no constant term, so I can't apply middle term break. So I factorize, take out the 4 and the c common, and then I take the 4 and the c common out from here. So I'm left with basically this thing right over here. And now I just need to solve my quadratic inequality, so that's really simple. I got these two factors. I'm going to put them equal to 0. 4c is equal to 0. C minus 3 is equal to 0. And so I'm going to be left with c is equal to positive 3, and c is equal to 0. So what do I do now? Well, I make my number line. this right here is my number line. I have 2 points of interest, 0 and 3. I'm going to go ahead and test them out in this form as well as in this form to find my answer. So I got this side right over here, I got this side right over here, I got this side right over here. So let's test out the first section first, and we can take any number. I'm going to take -1 and I'm going to test it out. So we got 4c, c minus 1, and it's actually instead of c, let's just go ahead and place that -1. -1, and then we're going to have -1, -3. All of this needs to be greater than 0. So this is going to be -4, this is going to be -4, and this is going to be -4 again. We're going to have positive 16 is greater than 0. This is true. So we put a tick on the section up there. This section is correct. And so we're going to go on to the second section. We can pick a value of 1 from over here. So we put a 1 in here, and we put a 1 in here, and we solve this out. So this is basically going to be 4. This is going to be -2. And so 4 times -2 is going to be -8. This is incorrect. -8 is not greater than 0, so we put a cross on that side. And then we got the final section, so we can use something. Let's say we can use the number 4 over here. So now all we got to do is put a 4 in there, put a 4 in there, and solve that out. So I put a 4, put a 4. 4 times 4 is 16. 4 minus 3 is going to be 1. And so this is going to be 16 right over here. It's greater than 0. This is true. We put a tick on that next section. So this section is also correct. So we got 2 correct reasons. One of them is basically going to be when c is smaller than 0 and c is greater than 3. So these are the set of values for c. And these set of values, if you go ahead and you look at the question, this was the question, it was this equation for the curve, this equation for the line, and they wanted you to tell them a set of values for c for which the curve and the line would intersect at 2 distinct points. And so this set of values, which includes anything that's below 0 and anything that's above 3, if you go and you put any of these values, let's say anything above 3, I choose that, so anything above 3 would be maybe 100. If I go ahead into those original equations, this one and this one, and instead of c I put the value 100, then the curve and the line are basically going to intersect at 2 distinct points. So we move on to the next problem, and it says a curve has an equation, y is equal to all of this, right? And then they give us an equation for the line, which is right this. And they say show that the line intersects the curve at 2 distinct points for all values of m. So what they're saying, they've already told us that for all values of m, so m is equal to anything, right? If m is equal to anything, what's going to happen is that the curve is going to intersect the line at 2 distinct points. So what they're saying is that if you look at this curve equation and then the line equation, this is the line equation, this is the curve equation. So the curve equation has this thing right over here, this thing right over here, which is basically this m. And what they're saying is that you can have anything in place of m. So 1, -1, 1,000, even 22 over 7, maybe 0.5, you can have anything in place of m. And you will always have a situation where the curve and the line intersect at 2 distinct points. And they've already told us that. We just need to show them that, okay, this is true. So how do we do that? Well, what does it mean to intersect at 2 distinct points, right? This is where your answer lies. This is the statement right over here. It means that the curve equation and the line equation, we know they're going to have a merged equation. And inside that merged equation, there's going to be a discriminant. And if that discriminant is greater than 0, then basically that means that the curve will intersect the line at 2 distinct points. That's what it means. So the discriminant of the merged equation needs to be greater than 0, or it needs to be positive. So that's what I'm going to do. I'm going to put the discriminant greater than 0 for the merged equation. So what is the merged equation? Let's first find that out. So this is the equation for the curve, 2x squared plus m 2x plus 1. I can clearly see this is a quadratic equation, and you can be like, well, oh, what is this weird form? This is not the standard form. This is not the vertex form. This is clearly not the vertex form, right? Because the vertex form is something like this. So you have your ax squared plus b plus c, and that x squared term is inside the bracket. We don't have that x squared term inside the bracket. In fact, it's outside the bracket. So don't confuse this for the vertex form just because it has 2 brackets. It's a weird form. We don't know what this form is. We haven't studied this form, but it doesn't matter. Point is, it has that x squared. We know that that is what a quadratic is. It has an x squared term. It's just not in any of the forms we recognize. So that's no problem. Don't worry about that for now. And this is the equation of the line. So let's first get this into its standard form. How do we do that? Well, if you multiply this m over here and over here, then you will basically get a form that you're more familiar with. So expand this out, and you're going to get 2x squared plus 2mx plus m. And now you can see it's actually in its standard form. So it's in its form ax squared plus bx plus c. And then what you need to do is to create that merged equation, you need to say this y is equal to this y. And so 2x squared plus 2mx plus m equals to 6x plus 4. Bring all of this to the other side. This is going to be 2x squared plus 2mx minus 6x plus m plus 4 is equal to 0. Now, this x and this x are common, so I'm going to basically, oh my bad, this was not a positive 4, this is actually a negative 4. And this 6 is going to go over there, this is going to be a negative sign. Okay, that's correct, and that's correct as well. So what I need to do right now is I can go ahead and take that x out as common, so I will have 2m minus 6, that x is out as common, and then I basically have m minus 4, all of this is equal to 0. Now this right here is the merged equation. What I can do is I can find out its discriminant, so the discriminant is b squared minus 4ac, and I need to put that equal to 0. I'll put that greater than 0. So this is going to be x squared plus bx plus c, and my b term has to have a square on top of it, and then I'm going to have minus 4 times a times c, and all of this is greater than 0. So I can apply the identity over here, and this is going to be a squared, so that is going to be 4m squared plus b squared, so that is going to be 36, and minus 2ab. So I believe that this is going to be 24m. So 2 times 2 is going to be 4, and then 4 times -6 is going to be -24. Yes, that is correct. And so this thing is going to solve out to give me 8, and then I'm going to have 8m and -8m, because there's this sign as well. And then that -8 is going to multiply with this -4, so I will get a positive 32 over here. All of this is greater than 0. Okay, so what I can do is I can see that this term has m, this term has m, these two are the constants, so let's solve this out. This is going to be 4m squared, and -8 and -24 should give me -32m, and if I add 32 into 36, I will get 68, positive 68, and all of this is greater than 0. Okay, so now I basically have to factorize this. It's a quadratic inequality. I know how to solve quadratic inequalities. I just need to factorize them. Or you can clearly see this is a quadratic inequality. And I'll have to multiply this 4 with that positive 68, but that's going to give me a huge number, and then I'll have to find a lot of factors to understand what two numbers. So if I multiply this 4 with 68, I'm going to get some number. Let's call that number a. I'll have to find out two numbers that multiply to give me a, and that add up to give me -32, and that's going to be a tough job. So what instead I'm going to do is I'm going to simplify this. I'm going to simplify this expression right over here. If I take 4 out common, I'm basically going to be left with m squared, and I'm going to have, I believe, 8m, and then 68 divided by 4 would give me 16, so I'll have, no, it'll give me 17, so I'll have all of this. So I'll have m squared minus 8m, positive 16, and then if I divide this 4 over there to the other side, so 0 divided by 4 is just going to be 0. So now I've simplified it, and I'm left with this. Okay, now I need to multiply this 1 right here with this plus 17, so I'll get plus 17, and I need to find two numbers that multiply to give me 17, but that add up to give me -8. Now, if any of you is smart enough, you will know that 17 is a prime number, and so it's impossible to find two numbers that are going to multiply to give you 17, but add to give you -8. Instead, the only two possible numbers that can divide 17 are 1 and 17. So you cannot factorize this further. You cannot do this first step. You cannot factorize this. And this is where there's a trick in this problem, is that sometimes you will have cases like this where you end up with a prime number and you cannot factorize it. So what do you do when you cannot factorize something? Well, if you cannot factorize it, try turning it into the vertex form. So let's do that. So I'm basically going to turn it into the vertex form, and I have my m squared minus 8m plus 17 is greater than 0. Now I'm going to apply my steps that convert a standard quadratic to a vertex quadratic. So I have this 8 over here. I'm going to divide it by 2, and I get 4. So now what I'm going to do is I'm going to have my m squared minus 8m plus 17. Remember, we leave some space in between, and in that space we add the 4, square it, and we subtract that 4 and we square it. So now we're going to create our two brackets, put a square on top. This falls in here, the sign falls in here, and this 4 is going to fall in here. And all of this is going to solve out and be put over here. So -4 squared will basically be -16, and -16 plus 17 is going to be +1. And so this is going to be greater than 0. So now we basically have this thing where we have m minus 4 squared plus 1 is greater than 0. Now obviously we're used to doing the factorization first and drawing the number line, but of course we couldn't factorize it. So now we just have this thing. We just have this vertex form, and we're left with this, and we got to make do with this. So you want to go back to the question, and the question said that show, it said the word show. So they already told us that for all values of m, the curve will intersect the line at two distinct points. Okay, we already knew that. We just need to somehow prove that is possible. So we have this thing which says m minus 4 squared plus 1 has to be greater than 0. We need to show that this thing right here is true for all values of m, And what is basically this thing? This means that this discriminant, which is now in its vertex form, this discriminant has to be greater than 0. We just need to show that for all values of m, it's greater than 0. It's correct for all values of m. This thing is always greater than 0, no matter what the value of m is. So how do we show that? Well, if you realize, then the only two possible values you can put in here for m are basically positive values. So if I write this thing down here, you have this m minus 4 squared plus 1 greater than 0. You can either put positive values in here, or you can put negative values in here. So you can put all of the positive values, you can put all of the negative values. And if you put all of the positive values over here, what's going to happen? Well, let's say you put 1 in here. What's going to happen? Well, 1 minus 4 and square that, and then plus 1 is greater than 0. Now what happens? You get a negative number, and you have to square that. What happens when you square that negative number? When you square a negative number, you're left with a positive number. And what happens when you add 1 to a positive number? Well, you still get a positive number. So if you have anything inside of this bracket, right? If you have any negative number inside of this bracket, it's going to be squared, and it will become a positive number. And if you add 1 to any positive number, you still have a positive number. So, and we know that positive numbers are greater than 0. All positive numbers are greater than 0. So it doesn't matter what value of m you put inside of this bracket. Even if you get a negative number, due to m being something, that negative number is still going to be squared, it's going to become a positive number, and then if you add 1 into any positive number, it's going to stay a positive number. And positive numbers are greater than 0. So no matter what you do, you will always get a positive number. No matter what value of m you input into this bracket, you will always get a positive value. You will always get a positive answer. And this thing, that discriminant is greater than 0, this thing will always be true because the discriminant will always be a positive number. It's not possible for it to be a negative number in this case. So that basically proves that the discriminant will always be greater than 0. And so we've already shown this thing. We've already shown you can say that the discriminant is always greater than 0. Greater than 0. So what we've shown over here is we've shown, the question said show this. So we've shown that by putting in any positive, by putting in any number over here, any value for m, what's going to happen is that we're going to have this bracket. This m minus 4 is going to solve out and give us this bracket. And it doesn't matter if inside that bracket we have a negative number or a positive number. If we square that, if you square a negative number, you get a positive number. If you square a positive number, you still get a positive number. So at the end, you're going to be left with that positive number. And if you add 1 into any positive number, you're still going to have a positive number. And all positive numbers are greater than 0. So we've shown it. Now we move on to this next question, and it again gives us this equation for a curve, and then this equation for a line over here. And it says that the curve and the line intersect at 2 points, which are A and B. And we have to show that the midpoint M, so the midpoint is called M, of AB. So these points of intersection, so they have a midpoint, right? If you join, there's going to be a curve, and then there's going to be a line, and then there's going to be points of intersection between them, which are going to be A and B. And so this line AB, this AB, has a midpoint which they call M. And what we need to show is that the coordinates of that midpoint are 1 by 2 and 7, 1 by 2. So we need to show that this midpoint is basically 1 by 2 and 7, 1 by 2. So how do we show that? Well, that's not really difficult. All we need to do is we need to know the coordinates for B, and we need to know the coordinates for A, and then we basically need to use the midpoint formula to find out the midpoint M, and we need to see if the coordinates we get match with these ones that are given to us in the question. So how do we do that? Well, we first need to find these coordinates for A and B, right? So how do we do? So we have this equation of this curve, and we have the equation for this line, so we can use the merged equation, which we know when we solve that merged equation, we basically get the points of intersection. So we get this line equation, which is basically given to us by y plus 3x is equal to 9. I'm going to get it into its form y is equal to mx plus c. So if I send this x over here, I'm basically going to be left with y is equal to negative 3x plus 9. And I have the equation for a curve, which is x squared minus 4x plus 7. So I need to merge them. I need to put this y equal to this y. And I'll be left with, x squared minus 4x plus 7 is equal to negative 3x positive 9. Now I send this stuff over there. So I'm going to have x squared minus 4x plus 3x plus 7 minus 9 is equal to 0. You solve this out, and you're going to have minus x. You solve this out, and you're going to have minus 2. And now what we need to do is this is the merged equation. We need to solve this, and so we will get our points of intersection. I'm just going to put an I over there. So how can I solve this? I can use all sorts of different methods. I can use quadratic formula. I can use the vertex form method. I can use factorization. And I'm just going to use my quadratic formula. So I'm going to have negative b plus minus square root b squared minus 4ac over 2a. So I'm going to have negative, and my b is minus 1, so I put that in there. And then I'm going to have minus 1 squared minus 4, a is 1, and c is negative 2. And then 2 times 1. And so I'm going to have two values for x, one for this positive sign, one for the negative sign. So I'll just solve this out. So one of the values is going to be minus 1, and the other value is going to be positive 2. So these are the 2 points of intersection. But remember, we only have their x coordinates as of now because we solved this equation for x. We still need to find the y coordinates. So how do we do that? Well, you can go into the equation of the line, or you can go into the equation of the curve, put in the x values, and you will get the values for the y coordinates of the intersection point. So I'm going to go in my equation of line, and I'm going to put first minus 1 in here. And this is just going to be positive 3, positive 9. So that's going to be 12, and then I can go ahead. So the y is equal to 12. And then I can go in here, and I can put positive 2. And so I'll be left with 3. So these are the two coordinates. This one right over here, this is going to be A, and this one right over here is going to be B. Now, how do I know that this was A and this was B? Well, because A comes first, then B. And see, this x has the coordinate negative 1. So negative 1 is, if I draw my x-axis over here, negative 1 is going to fall before positive 2. And so this has to be A and this has to be B. So I have my coordinates for A, negative 1 and 12, and I have my coordinates for B, which are 2 and 3. Now what I need to do is I need to use the midpoint formula to find the midpoint of these. So that's just basically going to be midpoint is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. So x1 is negative 1 as well as 2. So we negative 1 plus 2 divide that by 2. and then 12 plus 3, and we divide that by 2. So this is basically going to give us 1 over 2, and then 12 plus 3. So 12 plus 3 is basically 15. You divide 15 by 2, and you get 7 whole 1 by 2. Now we got the next problem, and it gives us two equations, an equation for a line and an equation for a curve. And then we need to show that the x-coordinates of the points of any points of intersection are given by the equation x squared minus 4x plus 3 minus a is equal to 0. And what is the equation that gives us the points of intersection? Well, we know that it's the merged equation. The merged equation gives us the points of intersection. So maybe this thing comes out of the merged equation. Let's find out. So we got the equation for the line, which is 3x plus a, and then we got the equation for the curve, which is x squared minus x plus 3. So we put y equal to y, and we get 3x plus a, and we get x squared minus x plus 3. So we can bring all this to this side, and we'll be left with 0 is equal to x squared minus x minus 3x plus 3 minus a. And so I'll be left with x squared, and I will be left with, if I add minus x into negative 3x, I will have minus 4x, and then I will have this constant term, which is 3 minus a. So you can actually see that this thing is the same as what they told us in the question. Now this thing right over here is going to give you the x-coordinates of the intersection points between your line and the curve. So the merged equation, they were basically asking for the merged equation, and we found that over here. Now we move over to our last question, and it says that the equation of a curve is this thing, and then the equation of a line is basically this thing. And we need to find the intersection points when k is equal to 8. So this equation has something that is in terms of k, and what we need to do is we basically got a curve, we got a line, and we need to put 8 in place of this k, and we need to find the intersection points between the curve and the line. Now before we do that, this curve equation is basically y squared plus 2x is equal to 13, and then the line equation is basically 2y plus x is equal to k. So this is the curve, this is the line. Now we have something weird going on over here. We don't have the square on x, instead we have it on our y term. So I didn't explicitly talk about these cases, but it sometimes does happen where instead, this is still a quadratic, okay? This is still a quadratic, because the only thing that makes a quadratic is you having a term, so let's say a y term or an x term or any term, which is raised to the power of 2. That's what makes a quadratic. So we have a quadratic equation over here. It's just that instead of having the square on x, we have the square on y over here. So what do we even do about this? So try and imagine it like this. So for this specific problem, all you got to do is imagine if the roles were swapped. If the x was y and the y was x. Okay, so just imagine that this thing is the vertical axis and this thing is the horizontal axis, right? Just try and imagine that for a second. So usually we see our equations in our quadratic equations like y equals ax squared plus bx plus c. Try to imagine to see it in the form, say x is equal to ay squared plus by plus c. Right, so just try and look at it that way. So what I'm going to do over here is I'm going to make x the subject. And so we need to rearrange this equation. And it's going to be, so we send the y squared to the other side, it's going to be 2x is equal to minus y squared positive 13. And then we can send this 2 over there to the other side, so it's going to be minus y squared over 2 plus 13 over 2. And I can write it in a different way, so I can write it like this, where I have minus 1 by 2 y squared plus 13 by 2. And now it's actually in the form x is equal to ay squared plus by plus c. So this thing right over here is c. We don't have a b term, so b is 0. And then the a term is basically this thing right over here. And so I can go ahead and do the same for this. I can swap the roles of x and y, and so I can basically get an equation in terms of x. I can get an equation for x, so I'll make it the subject. I send this 2y over there to the other side, so I'll have x is equal to 2y plus k, right? And the 2y is going to have a minus sign. So instead of having my equation in y equals mx plus c, I now have it in the form x is equal to my plus c. And this c is basically that k, m is basically this negative 2. Okay, so what does the question say? Now let's go back, and it says we need to find the intersection points when k is equal to 8. So all we need to do is we know that to find the intersection points, we basically need a merged equation. We need a merged equation. So let's form that merged equation, but before we do that, let's replace this k with 8, because that's what they told us. They said we need to find the intersection points when k is equal to 8. So we make the merged equation, and what we need to do is we just need to put the x over here to equal to the x for the curved equation, just like we put y equal to y, just like we put y equal to y over here. So we're going to say that x is equal to x, and so we have negative 1 by 2 y squared positive 13 over 2 is equal to minus 2y plus 8. So now what we can do is we can basically send this thing over there to the other side, and so we will be left with positive 2y squared minus 1 by 2y squared, and then this thing over there to the other side. So we're going to have plus 13 over 2 minus 8 is equal to 0. And this is 2. 1 by 2 basically means 0.5, so you subtract 0.5 from 2, you will get 1.5 y squared and you will get, you can solve this thing out, so I'm going to do that on my calculator. 13 by 2 minus 8 is going to give you negative 1.5 squared. Okay, negative 1.5, right? This doesn't have any other term with it. So we got this thing right over here. Now all we need to do is we need to solve this. This is the merged equation, right? We were finding the merged equation. So all we need to do is we just need to solve it, and we know that solving the merged equation gives us our points of intersection. So I'm going to put this in my quadratic, and this is going to be minus b. I don't have a b term, so this is just going to be 0. Minus b thing is just going to be 0. So minus b is just going to be 0. Then plus minus, I have b squared. Now b is again 0, so it's going to be 0 squared. Minus 4a, so 1.5. c, and c is minus 1.5, divided by 2, 1.5. So I'm going to get two answers, one for the positive sign, one for the negative sign. And if you solve this out on your calculator, the two answers you will get are, so we get 1 and minus 1. Now remember, in our previous examples, we were like, okay, these are the x coordinates, 1 and minus 1, but this time they're not the x coordinates. Why? Because when we were solving this merged equation, we were solving it for y. We weren't solving it for x. So the two y coordinates are going to be y is equal to 1 and y is equal to minus 1. But this isn't done yet. We just have the y coordinates. We also need the x coordinates of the intersection point. So we go back up, and you can either go ahead and choose your equation of line, or you can go ahead and choose your equation for curve. You put in the y values, and you find the x values. I'm going to go with the equation of the line. So x is equal to minus 2y plus 8, right? K was equal to 8, and I'm going to put this in here, and I'm going to put this in here. So x is equal to minus 2 multiplied by plus 1 plus 8. So this is going to be minus 2 plus 8. And this thing is just going to give me 6. And then I go ahead and I put my other y value in here, so minus 1 plus 8, and this is going to solve out to give me 2 plus 8. I'm going to get 10. So the two intersection points are basically 6, 1, and minus 1, my bad, 10, minus 1. So these right here are the two intersection points when k is equal to 8.